Hello everyone, welcome to Panda Power Education. Students, in the previous class, we already studied the charge distribution, that is line charge distribution. What is line charge distribution? The charges are distributed in a line, that means in a single wire, the charges are distributed. So, in that case, the line charge density, we are telling that that is called line charge density. Already discussed in previous class, that is line charge density. Okay, that is called lambda. Okay, if the charges are distributed in a line, single line, that is the charge are q, so many charges, that is q charges are distributed a line that is length l, then at that time we can say that that is line charge density. That means lambda is equal to, I am taking there dq divided by dl, because I am taking small amount of element, that is dl, where the charge is dq. Okay, तो ये सब जिनस मु ऑलरेडी प्रीवियस क्लास रे कहिथि, तो एठु केमिति चार्ज फाइंड करथि, दैट इज dq is equal to lambda into dl. Now integrate, I am integrating, and we can find that total net charge. Okay, if I integrated, then derivative will cancel, then you can get total net charge. That means when the charges are distributed in a single wire or single line. Okay, so in this class we will study another charge distribution. Second one is surface charge density or surface charge distribution. Write down. Second one is surface charge distribution. Okay, if the charges are distributed in a surface, that means I am taking a surface like this. This is a two-dimensional surface. There is so many charge are distributed here. I can tell that is charge is q. Q is distributed. Okay. Then you can find how much charge is distributed. So in that case, you can say that it is a surface. The line charge density को ले गोटे सिंगल लाइन में डिस्ट्रीब्यूटेड होतले, तो एठी सरफेस रे डिस्ट्रीब्यूटेड होय जे हम तो कहबा कोन सरफेस चार्ज डेंसिटी कोन कहबा सरफेस चार्ज डेंसिटी, सरफेस चार्ज डेंसिटी बुझिला. तो सरफेस चार्ज डेंसिटी डिनोटेड एज कोन सिग्मा, डिनोटेड एज सेठी जेंति लाइन चार्ज डेंसिटी हम कोन कहत डिनोटेड एज लैम्बडा, एट सरफेस चार्ज डेंसिटी डिनोटेड एज सिग्मा. दैट इज वैल्यू इज q divided by s by dq. I am taking a small amount of charge, that is dq. Okay, so dq divided by ds. Here ds is surface area, surface small surface. I am taking a small surface area ds, small surface area. I am taking a small surface area ds. This is ds I am taking. Okay, and in this small surface area there is charge dq. Charge is dq. Then I can find surface charge density is equal to dq by ds. Now you can take dq is equal to sigma into ds. So if you integrate both these, then you can find the net charge in the surface. You can find net charge in the surface. So you have to remember this formula. If in a problem is asking a surface, means charge are distributed in a surface, then you can use this formula to find the net charges. Okay, so this is called surface charge distribution. Now we'll go to volume charge distribution. Another thing is volume charge. Third charge distribution is volume charge distribution. Volume. Okay, just see, volume charge means three-dimensional object. You have to remember, surface charge means two-dimensional object, line charge means one dimension, and that is volume, that is three-dimensional object. That means I am taking what is a three-dimensional object. I can take sphere or cube like this. So I will take a cube like this. This one is cube. Okay, so you have to imagine so most of the charges means बहुत सारा चार्ज इट कोन हिजबो डिस्ट्रीब्यूटेड हेतिबो, पूरा टोटल क्यूब रे चार्ज गुला डिस्ट्रीब्यूटेड हेछि मन कर बुझिला. तो क्यूब रे एटा ଗୋଟେ क्यूब अछि, तो एटा क्यूब अछि तादर मन कर चार्ज डिस्ट्रीब्यूटेड हेछि, क्यूब अमाउंट ऑफ चार्ज एठी डिस्ट्रीब्यूटेड हेछि. तो एठी यदि तमे फाइंड करिवो, तो एठी तो सिंगल अमाउंट ऑफ चार्ज, सिंगल चार्ज नै, तो एठी कोन करिया टोटल क्यूब रे थिला एठी कोन वॉल्यूम बाहर करियो. सेठी कोन हिजो वॉल्यूम चार्ज अछि, एठी कोन आसीबो कांसेप्ट, सेठी जे सरफेस चार्ज डेंसिटी बाहर करथो, एठी सेठी कोन बाहर करियो वॉल्यूम चार्ज डेंसिटी. volume charge density, that means rho. Okay, that is called rho. So it surface charge density formula kon thila, ds is equal to dq by ds. So it is something rho is equal to dq divided by dv. तो small amount of volume नहीं गली, मन करा small amount of volume नहीं गली. Okay, that is dv. अब एठी चार्ज केते आवश्यक dq small amount, तो एठी small piece ताले एठी volume charge density केते हिजो, dq is equal to rho into dv. बुझियला, dv है वॉल्यूम, स्मॉल अमाउंट ऑफ वॉल्यूम. एठी इंटीग्रेशन कर देले हमें q नेट पाइ जिबा, टोटल चार्ज डिस्ट्रीब्यूटेड इन ए वॉल्यूम. बुझि पाछ, सेम स्फीयर रे नै परिबो. बुझि पाछ, स्फीयर गोटे पीस काटि की तमे कोन करिवो, इंटीग्रेशन कर देले हम पाइ जिवो टोटल नेट चार्ज इन डिस्ट्रीब्यूटेड इन ए स्फीयर. बुझियला. सो ये थिला कांसेप्ट थिला कोन, तीनटा चार्ज डिस्ट्रीब्यूशन हम पढिले, दैट इज सिंगल डायमेंशन ऑब्जेक्ट, टू डायमेंशन ऑब्जेक्ट एंड थ्री डायमेंशन ऑब्जेक्ट. इन सिंगल डायमेंशन ऑब्जेक्ट इफ यू आर लाइन, that means in a wire, so if so many charges are distributed, then you can find line charge distribution, that is lambda is equal to, I will write here, lambda is equal to dq divided by dl or q by l. You can find q by l. Another formula, second one is if the charges are distributed in a surface area, surface, that is two dimension object, then you can find that is called sigma. Sigma is equal to dq by ds. Okay, that is q by s. Okay, here that is its area. Okay, now if you find the if the charges are distributed in a three dimensional object like a volume or sphere like this, you can find that is volume charge density, that is rho is equal to dq divided by dv, that is q by v. Okay, these three formula you have to remember if charges are distributed in different object. Okay, so you can find easily in this type of charge distribution. Okay, so now we will go to a simple formula or simple problem, so you can easily understand. Okay, so just see. So I am taking a question number 1, write down question number 1. What charge would be required, what charge would be required, what charge would be required, a sphere of radius, a sphere of radius, a sphere of radius 25 centimeter, 25 centimeter, so as to get surface charge density, surface charge density, surface charge density, how much? 3 by pi coulomb meter. Okay, so that much of question is given. So just see how to find this type of question, how to attempt this type of question. You have to first you have to write the given, what is what information is given to in your question. So information is given a sphere, the charge, how much charge you have to electrify is given, electrify or write it, required, how much charge is required, how much charge is required in a sphere, that sphere having radius how much, 25 centimeter, radius 25 centimeter, I can convert it to meter, that is 0.25 meter. So there is a so as to get surface charge density is already given to you. Surface charge density how much? Sigma is given to you 3 by pi coulomb meter minus 2. Okay, this much is given to you. So you have to find how much charge is required of to a sphere to get this much of the surface charge density. Okay, so radius is given to you, so you have to find the formula. Surface charge density formula is sigma is equal to q by s. That means you have to require charge, he is asking to you charge, that means q is equal to sigma into s. And s is area of what? Sphere. What is the area of sphere? That is 4 pi r square. That means sigma into area of sphere formula, you have to remember that is area of sphere is equal to 4 pi, that is r square. Okay, you have to put this formula, the value, that is sigma is equal to 3 divided by pi into 4 pi into r square, that means 0.25 into 0.25. I can write. Okay, so now it is cancelled. Answer is coming 0.75 coulomb. Okay, 0.75 coulombs of charge required to get a sphere of surface charge density 3 by pi coulomb per meter minus 2. Got it? So this one is the simple question in asking your in your board exam. Okay. Next we'll go to another new topic that is called electric dipole. That is called electric dipole. Just see. Heading write down, that is electric dipole. Electric dipole. So write down the definition. Two equal and opposite charges. Two equal and opposite charges separated by distance. Separated by a small distance. By a small distance is called but electric dipole is called electric dipole. Okay, that is the definition of electric dipole. That means there is equal charges, but charges are opposite. That means if any plus q charge, another is minus q. Okay, but charge are equal. That means one charge is minus q. I'm taking one charge is minus q. Just see, minus q charge is there, and plus q charge here. I'll take plus q. That means he's asking equal. Equal means q is equal, and opposite, that is minus, another one is plus, and separated by a small distance. That distance is very small, that like micrometer, nanometer, like this. Okay, so that distance is very small, separated distance. So ei type jodi dinso tame dekhibo plus q और minus q charge pakha pakhi very small distance रे thibe, then that is called electric type. बुझिला तो एठी डिस्टेंस तुम d नबनी, तो डिस्टेंस d काहे कि नबनी, तो डिस्टेंस d तुम नहीं परियो किछ असुविधा नै, बट आको भीतर डिस्टेंस तुम जहां भी नहीं परियो बुक रे बेसिकली तुम बुक रे सिग्निफाई करै जे एटा ओरिजिन नै छै आको भीतर मिड पॉइंट को मध्ये ओरिजिन नै भी एपट रे नेगल डिस्टेंस a एपट नेगल डिस्टेंस a ताल ताको भीतर डिस्टेंस नै गला ए सेम फैशन रे सब बुक रे लिखाई आई गो बुक रे l लिखाई को बुक रे a लिखाई ताहले आमे कोन लिख नै जिबा एई फैशन रे लिखबा त तुमको मु दु एटा डी नेबी ताले हेई परिबो किछ असुविधा नै, बट एठी सेही फैशन रे लिखाउ जदी बुक रे लिखाइ छै सेही हिसाब रे तुमको लिखै दै छी. दैट मींस जदी दीटा इक्वल एंड ऑपोजिट चार्जेस गोटे स्मॉल डिस्टेंस रे सेपरेशन टू ए डिस्टेंस रे सेपरेशन हेई थांती ताहले सेमे इलेक्ट्रिक डाइपोल सेटा को कहबा इलेक्ट्रिक डाइपोल. बुझि परछन नै? तो दिस इज द कांसेप्ट ऑफ इलेक्ट्रिक डाइपोल. सो एठी another concept, another term is coming, that is called electric dipole moment. That is called dipole moment. Okay, dipole moment, that is p. So it is a vector quantity. What is dipole moment? What is dipole moment? Write down. It measures the strength of electric dipole. It measures the strength of electric dipole. Okay, dipole moment it measures the strength. ये जो इलेक्ट्रिक डाइपोल लो स्ट्रेंथ को के मेजर करिवो ना डाइपोल मोमेंट आर ओटे डायरेक्शन अछि. एटी डायरेक्शन कोन या हेछि ना माइनस नेगेटिव रु पॉजिटिव चार्ज. डाइपोल मोमेंट रो मन रखिबो डाइपोल मोमेंट रो डायरेक्शन ऑलवेज नेगेटिव टू पॉजिटिव. ता माने ए आडको दैट इज p वेक्टर ऑलवेज नेगेटिव टू पॉजिटिव. दैट मींस डायरेक्शन always take negative to positive. Got it? So dipole moment, it measures the strength of electric dipole. So how much? Just see, there is a formula p vector is equal to q into 2a. Product of any charge. तुम charge उठेली बोले q ताको इधर distance. है. That is the electric dipole moment. Okay, dipole moment is the electric dipole moment. It measures the strength of the electric dipole. बुझिला पिला माने तो आ ऊपर हमें गोटे प्रॉब्लम करबा तुम इजीली क्लियर हो परिबो केमिति इलेक्ट्रिक डाइपोल हम फाइंड करबा. बुझिला गोटे प्रॉब्लम सिंपल गोटे प्रॉब्लम करछ देखो. बुझिला इलेक्ट्रिक डाइपोल और इलेक्ट्रिक डाइपोल मोमेंट भीतर यदि डाउट हो तो पॉज करके बारंबार वीडियो देखले पूरा आराम से बुझि परिबो. किछ असुविधा होनी. और एई क्वेश्चन तमरो बोर्ड एग्जाम पर रिपीटेडली पचरछि. लॉन्ग क्वेश्चन हम करबा नेक्स्ट क्लास रे डेरिवेशन करबा कोन ना गोटे डाइपोल रे लाइन रे मु कोन बाहर करबी इलेक्ट्रिक फील्ड बाहर करबी और परपेंडिकुलर डिस्टेंस रे इलेक्ट्रिक फील्ड को बाहर करबी और एनी पॉइंट रे इलेक्ट्रिक फील्ड बाहर करबी और एई जो क्वेश्चन ता जो डेरिवेशन ता करबी सेटा रिपीटेडली क्वेश्चन तमर बोर्ड रे आछि बुझियला। तो देखो गोटे प्रॉब्लम कर दूची आ बेसिक डाइपोल मोमेंट बेस ऊपर। सो क्वेश्चन नंबर 2 लेखो फाइंड नेट डाइपोल मोमेंट फाइंड नेट डाइपोल मोमेंट फॉर द system is given to you a system is given to you. In this system you have to find the net electric dipole that is net dipole moment. The system there is a system the charge this is x axis, this is y axis. System is given to you, this is origin. A charge is present, this is -2q charge, -2q charge is present at origin, and here +q charge is present, here +q charge is present, here also +q charge is present. But this distance is given to coordinate point is given to this is a comma 0 and this is 0 comma a is given to. So here in this system you have to find the dipole moment, net dipole moment. Just see you can how to approach this question. Very important question. You have to approach. How to approach? Just see, this is -2q. You can break it into two parts. That is -q. Also, you can write -q in this origin. So you can easily find out here -q to +q. A dipole moment also you can find -q to +q dipole moment. And distance is given to here distance is given to you a. Also here distance is given to you a. Okay, you can easily find. Just see, if I take here dipole moment is P1 vector and you can take here dipole moment is P2 vector. Just see. So first you have to find P1 vector. How much? Q into q charge is q into distance is a. That means q into a. Distance between two charges, that is a, and q is charge is q. Okay. Now P2 vector. How much? Q here also q charge is q and distance how much? Also a. Okay. So you have to find now a net dipole moment. Just see one dipole moment direction is -2 plus one dipole is P1 vector is like this and P2 vector is like this. Yes or no? What is the resultant field? Resultant field like this because it is a vector quantity. So how much you have to find? P vector is equal to, that is net dipole moment. P net is equal to here what is the formula? P1 square plus P2 square root over, and cos this is 90 already come 1. So now 2p that is formula is 2p1 p2 cos 90 na angle kete 90. So eta 1 he gala tale roila kete p1 square plus p2 square root over this much is q a, that is q square plus q square root over, that means 2 q square root over, that is root 2 q a. This is root 2 q a. This is net dipole moment in this system. बुझियला? Clear or not? आउ थरे कहि दोची देखो एठू डिस्टेंस तमर कते एटा a अछि एठू डिस्टेंस कते x एक्सिस रे a एठी डिस्टेंस a मो एठी -2q चार्ज नेथिली दीटा चार्ज हे गला -q आ पय हेला -q + q एठी ला -q + q एठी मो डाइपोल मोमेंट इजीली फाइंड कर देली. डाइपोल मोमेंट रा फार्मूला कोन? चार्ज इनटू प्रोडक्ट ऑफ चार्ज इनटू डिस्टेंस बिटवीन देम. The product of charge के q into distance between them कहते a एठी से यार product of charge into distance between them. तो तार resultant field बाहर कर दो. वेक्टर resultant field फॉर्मूला कौन? p is equal to p1 square plus p2 square plus 2p1 p2 into cos थीटा. थीटा कहते 90 डिग्री into root over. तो फाइंड कर देली. बुझिला ना नहीं बुझि पाइलनी. तो नेक्स्ट क्लास रे हम वेरी इंपोर्टेंट क्लास नेक्स्ट क्लास कहनी होची. तो नेक्स्ट क्लास रे तमरो डेरिवेशन हो डाइपोल इलेक्ट्रिक डाइपोल बुझिला दीटा डेरिवेशन हो. गोटे तम इलेक्ट्रिक डाइपोल लाइन रे फाइंड करबी इलेक्ट्रिक फील्ड केते आ गोटे परपेंडिकुलर रे केते आ एट एनी पॉइंट जोटा कि तमरो बोर्ड एग्जाम रे रिपीटेडली क्वेश्चन आसी. बुझिला? थैंक यू.